Hello and welcome. In this video, I'm going to complete a series of tasks for segment routing on OcNOS devices. The task is as follows. It says that make sure the single level ISIS is configured on OENet Solutions Network. This is OENet Solution Network. You can just decide whether this is a service provider or a data center, because on OcNOS devices, segment routing could be enabled both on data center and service provider devices. So I'm not just going to decide whether this is a data center or a service provider. In case this is a data center, these are the tenants. And in case this is a service provider, then these are going to be customers. So I'm going to just say OENet Solution Network. And then there should be no pseudonode LSPs in the database, which means that all the links should be point-to-point. And we are not going to have a designated intermediate system here. And finally, we are going to configure segment routing on all network devices. This is because we really want to make sure that the destination is reachable via the path that we decide. Let's say that, for example, I want to go from router 3 to router 6. And based on IGP, I have some paths to get to the destination. Let's say that based on IGP, I could go to router 1, from there to 5, and from there to here. This is going to be 3 hops. And let's say that we are using ISIS as the underlay IGP, and all the links have a default cost of 10. This is going to give us a cost of 30 to get to the destination. So that's going to be this one. In case I take another path, let's say, for example, I go to router 1 and from there to router 2 and from there to router 6, then it is going to have a cost of 30 as well. But you know that I can just take some longer paths to get to the destination, and they are going to have higher costs. But this is not exactly what I really mean by that. What I really mean by segment routing is, let's say that for some reason, I want to go from here to here, then to here, and then to here. And maybe this is not the best cost path to the destination, but I really want to take it. Well, let's say that, for example, instead of this, I want to go to here, from here to here, and then to here, here, and finally here. You see that based on cost, this is not the most effective path to the destination, but for some reason, I really want to take this one to get to the destination. Now, what is the difference between what we are doing in segment routing and something like, let's say, RSVP? RSVP is stateful. What you really want to do is to reserve the path from the source to the destination. You are going to decide what the bandwidth is that you're reserving, and then all the routers through the path should accept the path and should just, kind of acknowledge that they are going to be in this path. And also the MPLS network is going to be created for us. Maybe LDP is going to be used for the labeling. But in segment routing, we don't really need to have any state in here. What I really want to do is, I'm just saying that this packet should use this label and this label and this label, just go to the path that I really want to, and then I send it to the destination. That is what segment routing is going to do for us. And the other thing is, in segment routing, I can just advertise the labels using the IGP. And here, of course, IS, and also OSPF are supported for advertising the labels. So I don't really need to configure anything like LDP in here. And these are going to create the labels, and we can just see it in MPLS forwarding table. Next thing that I really want to configure is some labels on each one of these. And let's say that these are going to be called segment IDs. I'm going to create the segment IDs using index, not absolute value, but you can configure this as an absolute value. First of all, I should say that what I'm trying to say here is not the actual term. The actual term is segment routing global block. And that is it, but I can just call it the label space that we are going to use it. Okay, so the label space, or the sRGB, the global block, starts by default from 16,000 and ends to 24,000. This is actually one less than 24,000. Okay, so what I mean is the labels are going to be selected from this space. Now you can just decide that the label space is something else, the global block is something else, or you can just use the default. There is no reason to change it. In case there is a reason, you can just do it. I'm not going to change it, but I'm going to show you how you can do this. Okay, so this is the global block, and next is this. I'm just using one of these labels, one of these values, and I'm just assigning to each one of these routers as a segment ID, and that is going to be completely unique throughout the network. Let's say that, for example, for router 1, I'm using 16,001, for router 2, 16,002, for router 6, I'm using 16,006. I can easily decide based on these labels who owns this segment ID. And also, of course, I can just decide that the path should be from this to this to this. And I'm just using the labels. If you go with absolute value, this is what you are going to configure. So you say, okay, absolutely, I'm using this one. There is another one which I'm going to use, and this is called based on index. Index says, okay, so I'm going to give it seed. So let's say, for example, seed of 100. And then I'm going to assign it to here. On router 1, I'm going to say, okay, the index is 100. So it is going to take a look at sRGB label space, and it will see that 16,000 is the beginning. It's going to add this 100 to that, and this is going to be assigned to the router which I am just configuring. So let's say that I'm going to say the segment ID is based on index 100, and starting is 16,000. So that's going to be 16,100 assigned to this router. So that is going to be a very basic configuration of the SID here. The other thing that I want to do is I'm going to enable MPLS. Like I said, MPLS should be enabled because I'm just advertising every label into MPLS forwarding table. An MPLS forwarding table is going to be created based on the labels, and for that there is just one single command which are going to be configured under each one of these interfaces, which I have deliberately changed the color to red. You can see that the red interfaces are going to have MPLS configuration using label switching. I don't have to configure LDP because LDP is not going to be used here. ISIS or OSPF are going to interact with MPLS, and they are going to populate the MPLS forwarding table. So that's the very basic overview of what we are going to do in here. So let's start doing this, and in the next video, of course, I'm going to start working with these customers or tenants, whatever that you want to call them. So let's go to one of these routers. Let's say, for example, router 1. You can see that the IP addresses are pre-configured here. ISIS is not configured. What I have done is, this is the primary IP addresses for physical interface, and this is the secondary IP address for the loopback interface. Using show IP interface brief secondary, you can just check what you have assigned to each one of these interfaces as a secondary IP address. Currently, loopback interface only has this one. Okay, so let's start the configuration of ISIS here. So what I'm going to do is to go to configuration mode, and later I'm going to just copy the configuration and change it and apply it to other routers. I'm going to say router ISIS, and let's say the name is OE. Now I'm going to use this throughout my whole network, which means that the whole network is going to be one domain. And this domain is going to be used for segment routing as well. So you can create multiple domains, but here I'm just going with one domain only. So the net value, let's go, this is going to be with 49. For area number, I can just put anything, let's say 1, just for simplicity. And then for the net ID, for the device ID, of course, you can just configure anything. You can embed some information in that. What I'm trying to use is just router number, nothing more than that, just for the sake of simplicity. So 0000, 0000, 0001, that's it, and end selector is always 0. Okay, so that is a simple configuration of ISIS, and let's just configure the interface first, and then come back to ISIS and add stuff that I really want to. So interfaces are going to be each 1, 2, 3, 4, 5. So let's just go with some of the commands, and I'm going to just write them here. First of all, I should say label switching, because we are going to make sure that MPLS is enabled under them. The other thing that I want to configure is IP router ISIS and that would be OE, which is going to add this interface to ISIS database. The next thing which I want to configure is ISIS network should be point to point. So if I'm correct, the configuration should be something like this. And also, just forgot to do something. I need to enable IS type as level 2 only, and also ISIS metric style, or just type metric style, is going to be while. Why am I using metric style while? As a matter of fact, for traffic engineering, for some other features that we are going to use, metric style of wide is something which is necessary. So you can just configure metric style wide under each one of the interfaces, or you go with the default metric, which is 10. So I'm just going to say commit for this part. And then let's go back to each one of the interfaces. So these are the configuration of each one of the interfaces that I want to have. And also I can add metric to that, but no, I don't really want to. So I'm just copy this and then go to interface EAT1, and I'm going to paste this series of configuration: EAT2, EAT3, EAT4, EAT5, interface EAT5, and finally interface loopback. It's just going to have this line because that's a loopback interface, right? So I'm going to say commit. Okay, the configuration on this side is not completely done. I need to add some stuff to ISIS. So let's go back to ISIS, rather ISIS OE. So under this, what I need to do, first of all, let's just change something. Dynamic host name is going to make sure that instead of system ID, I see the rather name. That is going to simplify the matters. Maybe you do not really need to have it in your production network, but I prefer to have it right here. Next thing is I want to enable segment routing for this. Like I said, I can just go with segment routing. And then after that, you can see that we have segment routing MPLS. And of course, there is nothing more than that. But if I want to change the global block or the label space, like I said, you can just say ISIS segment routing. And here you can see that global block can start from whatever number and end to whatever number that you really want to, because you can see that the label space is very huge. You can just select whatever you want to. But for now, it starts from 16,000 ends to 23,999, which gives you 8,000 labels, and that is more than enough for my network. Okay, so I'm just going to say commit again. And here there is a problem. It says that MPLS-T is not enabled on this levels. I need to configure this because this is mandatory. So on some platforms, you don't have to do this, but here I need to say MPLS traffic engineering should be configured for level 2. You can configure it for level 1, but I have only level 2. So that is the only thing that I want to have it here. Okay, so let's save the configuration. First of all, just make sure that this is going to be saved to our startup configuration. So I'm going to say show run rather ISIS. This is the configuration which I'm going to copy and I'm going to replicate on other routers. So let's just do this. I'm going to paste it here. For router 2, the only difference is this one. So I'm going to copy this and go to router 2, configure terminal, paste it, and commit it. For router 3, I'm going to change it to 3. And I'm going to copy that again. Here, configure terminal, paste, commit. Okay, for router 4, this should be 4. And I'm just going to copy that and go to here and say configure terminal, and paste it, and for some reason it didn't get pasted, so maybe I have not copied this. Okay, and commit. For router 5 I need to do this, and then copy, go to configuration mode and paste it and commit it. And finally router 6, which is going to have the system ID as 6. Okay, so let's go to configuration mode and paste it and commit the configuration. Okay, the first thing is done. Now, something that should be configured under loopback interface is the SID, as I told you. So I need to go to interface loopback, and under this I should say prefix SID. There are two options, absolute and index. Like I said, I'm going to go with index, and I'm just going to say okay, index is 100, which means that this is going to be 16,100. The label which is going to be generated for router 6 is going to be this one. So, or let's say that no, this one, maybe this is going to be 600. That would be better. Okay, so let's just remove this line of command. I'm not so sure. Oh, look, it has replaced. So I'm going to say commit. So if I just say show run interface loopback, now you can see that I have this, and also I need to, of course, configure this. I have also pre-configured this before, so this is here. That's okay. So let's go to router 2 and the interfaces which I need to configure something under them. So if I just say here show run interface EAT1, the part that I'm going to configure is these commands. So under router 2 it would be 1, 2, 3, 4, 5. So let's do that. Interface EAT1, EAT2, interface EAT3, EAT4, EAT5. That's it. Commit the configuration. On router 3, what I have is 1, 2, 3. Interface EAT1, interface EAT2, interface EAT3. Commit the configuration. On router 4, what I have is 1 and 3. Interface EAT1, interface EAT3. Commit the configuration. Later I'm going to make sure that loopback interface has this as well. On here, what I have is 1 and 5. EAT1, EAT5. Commit the configuration. And finally on router 6, what I have is 1, 2, 3, 4, 1, 2, 5. EAT1, EAT2, EAT5. Okay, and loopback interface has this command on here, but others do not, I guess. So I'm going to say interface loopback, this one. Commit the configuration. Interface loopback, commit. Interface loopback, commit. Here, interface loopback, commit. Interface loopback, commit. And we did it on router 6. So let's just say commit. Okay. So let's say end on all of the devices and save the configuration just to make sure. I'm just doing it 2 times out of habit. Okay, so my configuration is almost done. I'm just going to check everything here. So there are some verification commands which I really need to use them. The first and the simplest one, of course, is to check the adjacencies on these routers. So I'm going to say show CLNS adjacency or CLNS neighbors. And based on the configuration, router 6 should be neighbor with 125. So that is router 6, 5, 2, and 1. That's correct. On router 1, I should be 2, of course, with 2 different links. That's okay. 5, which is here, and also 6 and 3. 6 is directly connected and 3 is here. So everything seems to be fine, most of them, and I can just check all of them, but that's okay. Next thing is going to be checking my routing table. So I'm going to say show IP route. So I'm just going to check to make sure that all of these routers are available. So it says 1 is there, 2 is there, 3, 4, 5, but where is 6? 6 should be there. So if I just say show run interface loopback, it says that we have configured IP router ISIS-OE under here. And 1, 2, 3, 4, 5, 6 is available. So let's go back to router 1 and see why 6 is not here. So 6 is not here, although 6 is a direct neighbor. Let me just see something. Show ISIS interface. Hit enter and it should go with brief, of course. What is it that we have? No, we don't have anything. So in here we have the E1, E2, E3, E4, E5, and finally loopback is here. So I should see 6666 after some time. For some reason I'm not seeing it here. That's okay, no problem. I'm going to troubleshoot it later. On router 2, I have all of these 1, 2, 3, 4, 5, 6. On router 3, I have 1, 2, 3, 4, 5, 6. On router 4, I have all of them. On router 5, all of them. On router 6, all of them. And for some reason, 6666 is not applied to router 1. Maybe there is a misconfiguration. So if I just say show IP interface brief, secondary here, we have 1111 and nothing conflicting. I can just check it later, no problem. Okay, so the next one is I want to make sure that the capabilities here for ISIS neighbors, if I just say show IS neighbors, what I'm going to say is, let's say for example, ISIS neighbor for router 1 is router 3. 3. And on ETH1, of course. ETH1. Okay, on ETH1, we have router 3 as our neighbor. So this means that we have the adjacencies completed. Now, what I'm going to say is show ISIS, and after that you can see that there is an option that says segment routing. This one is important. And then I have capabilities right here. So I'm going to check this and later state, of course. I'm not going to go through all of these routers, but you can see that, for example, for one of the routers, which is 2222, you can see that the total seats supported are 8,000. The global block is 16,000 to 23,999. So I can see that here. So the neighbors are available for me. And if I just go a little bit more, maybe I'm going to say state as well. I can see that a very short listed items of from this list, of course, is going to be visible for me here, but the most important state is SR enabled. That is the most important piece of information that I really want to have. Now, the next thing that you need to know is show ISIS database. So by default, the database is going to be visible for you, but if you go with something more in verbose, show ISIS database verbose, that's going to give you a lot of information, which some of them seems to be very important. First of all, The first part, of course, gives us some information about the neighbor, the area which the neighbor is inside, and everything. So all neighbors are in area 1, as you can see, per configuration. And then if I just come down here, you can see that I have some information about segment routing. You can see the base ID is going to be 16,000. The global block consists of 8,000 addresses. And if I just go down again, traffic default metric is traffic engineer, of course. Default metric is 10. Adjacency SID is 25,600. This one is super important. For each interface, you can see one difference. So in here, you can see that for this specific neighbor address, 10.1.201.21, and this one, the adjacency values are different, 25,600, 25,601. So for each interface, this is going to be created separately. And although I am receiving these values, but they are locally significant, which means that for the last hop, maybe they are going to use this one to get to the destination. This is one of the information which is important for them. And next is some others stuff here, such as the metric to each one of the neighbors that we have in here. And some more information that we can check to see here. The other command which I'm going to show you, of course, is ping. But before that, let me see if I have missed any verification commands in this regard. So based on what I have, the ping is going to be the next one. But let's check something. I just forgot to tell you that there is MPLS forwarding table which is populated. And because most of the routers are my next hop, you can see that most of them receive this implicit null label. But the actual label, for example, to get to something which is not in direct neighborship with me, is the label that I have. So to get to 4444, as you can see, my out label is going to be 16,400. And the next hop, of course, is going to be this one, which means that I am going to send the packet to 4444 through 10.1.3.3, and on top of that, I'm going to allocate this label. This is exactly what we just assigned to the loopback interface in there. So you just saw that, and forwarding table, of course, is going to be on all of these routers. But if you want to get more information on each one of the FECs separately, instead of forwarding table, what you are going to say is show MPLS. There was something here, FTN table. So that is what I'm trying to check. And this is going to give you a lot of information about each one of those entries. For example, this one, 3333. And the most important part is going to be this one, next hop. And also the, what is this? I'm trying to find something to show you. You can just check the information and see. The owner is, of course, is ISIS-SR. I'm going to use this one for pinging, which is interesting. Okay, so let's go for a ping. I'm going to say ping 5555. You can see that ping is going through. Okay, so if I say ping 555, and I'm going to say source IP is going to be 1111, the ping goes through without any problem. But this is not using segment routing. I'm going to use segment routing. So for that, I would say ping, and after ping, you can see that there are some options. MPLS is one of them, and now you can choose what you really want to do. Previously, we have used ping MPLS LDP when we were configuring L3 VPN. Okay, now we are using ISIS segment routing because we just configured it under ISIS. So I'm going to say ping ISIS segment routing. The destination is of type IPv4, and that's going to be 5555/32. And I can just hit enter. This is going to show me the ping, but I really want to see more detail about that. So for that, I'm going to say detail, and you can see that now this is giving me more detail of each one of the packets that are sent to the destination. Similar to this configuration, it doesn't really show where the packet goes. It just says that packet goes through. I can just use trace, but you see that there are two commands. One of them is trace, the other one is trace route, and both of them, of course, say trace route. So for trace route, we don't have MPLS option, so I need to go with trace, and you can see that there is MPLS option after that. Again, ISIS SR is going to be used, and I'm using not a policy, I'm just using IPv4. The destination is 5555/32. And after that, of course, I can go with some detail and hit enter. You can see that it goes to the destination, and you can see that it is using implicit null because router 5 is just one step away from me. So maybe I should go from 3 to 5. Let's do this. So if I just say trace of MPLS ISIS IPv4, and the destination is 5555/32. Or maybe I didn't type /32 on there, right? I'm going to say detail and hit enter. Now you can see that it is using this label, and after that the label is going to be popped, and then in the third step it goes to the destination directly. So you can use ping and trace to get to the destination, and you can see the labels are here. I can check the labels exactly. I have two types of labels, in label and out label. For them, I can just say show MPLS in label, and you can see that in segment table, this one, which is going to be my in label. And for each one of them, of course, you can see a lot of information, very much similar to the previous command that I used, but that is going to show you more information about the in label here, as a matter of fact. And also I can just say out segment table, and that's going to give you some more information about the tables that are assigned to each one of these. You can see that most of them, of course, have out label as 3, which means that we have just one step to the destination, or we are right next to the destination. This one, for example, is not exactly connected to the destination, so this one is 16,600, the next label. Okay, so we just configured MPLS under each one of the interfaces, ISIS under each one of the interfaces. All of them are point-to-point, and the configuration was done completely. Our network is created. The next step is going to be, configuring our tenants or customers. In the next video, I'm going to do that. So I hope this has been informative for you, and see you in next videos.